We're going to explore how smart genetic management isn't just about tiny improvements. It's about unlocking whole new levels of productivity and resilience for aquaculture.
It is kind of a paradox, isn't it? We're farming nearly 700 aquatic species around the world.
Yeah.
Yet if you compare aquaculture genetics to livestock or crop breeding, it's, well, still pretty underdeveloped in many ways.
But here's the interesting part. That's actually a massive advantage. The amount of genetic diversity we see in aquatic species is often huge. Why? Because many were domesticated relatively recently, and their wild relatives are still out there.
A whole new era of communication in the global aquaculture industry is coming. Now you have the brightest minds in aquaculture right in your pocket. And what's best? You can listen to all of them while driving to a farm, traveling, or running errands. It's never been this good, and it's never been this simple. Welcome to the Aquaculture Podcast Show, the first AI-based podcast in aquaculture, where you'll find cutting-edge insights in everything that's working in aquaculture, nutrition, health, and production.
Welcome to the deep dive. Today, we're jumping straight into the genetic future of aquaculture. It's a field that's absolutely fundamental to global food security.
Definitely.
We're focusing on aquatic genetic resources, basically the genetic blueprint for farmed fish and shellfish, and how managing these resources strategically is, well, crucial for the whole industry's sustainable development. You know, you might think, given how big aquaculture is globally, that its genetic side would be as sorted as, say, terrestrial farming.
Yeah, that's a common assumption.
But it's not quite like that. There are unique challenges, yes, but also some really huge opportunities there. So, okay, let's unpack this. We're going to explore how smart genetic management isn't just about tiny improvements. It's about unlocking whole new levels of productivity and resilience for aquaculture.
It is kind of a paradox, isn't it? We're farming nearly 700 aquatic species around the world.
Yeah.
Yet if you compare aquaculture genetics to livestock or crop breeding, it's, well, still pretty underdeveloped in many ways.
But here's the interesting part. That's actually a massive advantage. The amount of genetic diversity we see in aquatic species is often huge. Why? Because many were domesticated relatively recently, and their wild relatives are still out there.
Ah, okay.
So we have this vast, largely untapped pool of genetic variation to work with. We're really just starting to figure out how to use it strategically.
And that's where it gets really interesting. We're talking about potentially significant targeted gains, not just minor tweaks.
Exactly. Take selective breeding. In some aquatic programs, we've seen average genetic gains per generation hit up to 13%.
13%? Wow.
Yeah, that's often faster than what you see in many terrestrial systems. And these aren't just numbers. These improvements are for key traits: faster growth, better disease resistance, tolerance to environmental shifts like temperature changes.
Things that directly impact the bottom line and sustainability.
Precisely. It means higher productivity for farmers, which helps meet food demand, but it also supports broader sustainability goals, making the whole system more efficient and resilient.
Why Genetics turns podcast airtime into brand authority. We don't sell ads, we elevate voices. Curious how far your voice can go to become a reference in the industry and attract more leads? Scan the QR code and discover how we can turn your expertise into unmatched brand authority. Let's transform expertise into influence, starting now.
So what this all means is we have this incredible yet relatively new genetic foundation to work with. A huge asset if managed right.
Indeed. But it's not without its complexities.
Yeah.
Now, while it's true, most farm populations still have decent genetic diversity thanks to that recent domestication. Like you said, 97% just in the 20th century. The sector does face some serious limitations. One big one is having base populations that are just too small to start with.
Okay, and what does that lead to?
Well, it can quickly cause inbreeding and a loss of that valuable genetic variation. We call it genetic erosion. There's also the risk of hybridization, especially when you have closely related species farmed near each other. Genes can mix, dilute desirable traits, and sometimes even threaten unique local species or strains.
That sounds concerning.
It is. And what's really alarming is that for up to half the species we cultivate, we don't even have a proper conservation status assessment. We just don't know how threatened their wild counterparts might be.
That statistic is definitely a wake-up call. So this raises an important question. How do we safeguard this genetic goldmine? What are the key strategies for protecting this vital diversity?
Well, the primary focus really has to be on conserving the wild relatives. They are the essential reservoir for future breeding. They hold the raw material.
Right. The genetic insurance policy.
Exactly. Most conservation efforts right now are either in situ, protecting them in their natural environment, or in vivo, meaning keeping live collections. But we hit a technical wall with long-term genetic banking, especially cryopreservation.
How so?
We can freeze sperm pretty effectively for many species now. But freezing eggs or oocytes and embryos, that's still largely experimental, very difficult for most aquatic species. And that really limits our ability to create comprehensive long-term genetic banks like we have for some terrestrial species or crops.
So the long-term comprehensive banking of genetic material is still a hurdle. What advanced tools or approaches are on the horizon to help overcome these monitoring and conservation challenges?
Yeah, that's key. The future really depends on developing more cost-effective genetic tools. Things like advanced marker technologies or using environmental DNA, detecting species from traces of DNA in the water.
Okay.
These tools need to be affordable and accessible, especially in developing nations, so that robust genetic monitoring isn't just limited to well-funded labs. That's crucial for effective conservation everywhere.
Let's pivot slightly to a topic that has driven production but also carries inherent risks.
Yeah.
Introduced species. 9 out of the 10 top aquaculture species are farmed outside their native ranges. What's the deep dive take on managing these introductions responsibly?
Right. It's a huge factor in the industry's growth, no doubt. But it's definitely a double-edged sword. These introductions have massively boosted production, yes, but they've also caused significant ecological and genetic problems in some cases.
Like the tilapia example.
Exactly. Certain tilapia species, introduced widely, have unfortunately displaced or hybridized with native fish across Africa, messing with local biodiversity. So it highlights the absolute need for really robust risk assessment before introducing a non-native species or even a genetically improved type.
And what should that assessment cover?
It needs to be comprehensive ecological impacts, genetic risks, economic factors. We should be using structured frameworks, thinking about escapes, hybridization potential, disease transmission, competition with native species, all of it.
Makes sense.
The trouble is, we often lack solid empirical data. So many risk assessments end up being more qualitative, less based on hard numbers than we'd like.
It sounds like better data and science-based decision-making are paramount. But what about proactive genetic improvement? Selective breeding has transformed terrestrial agriculture, yet it seems underutilized in aquaculture.
That's absolutely correct. It is underutilized globally,
That's
despite clear proof of its impact. We have success stories. Specific improved strains of Nile tilapia, for example, show huge productivity jumps.
But they're the exception, not the rule.
Largely, yes. Globally, only about 10% of aquaculture production comes from these improved strains. A massive 40% still relies on basically wild, unimproved fish or shellfish.
Why is that? What are the roadblocks?
Several things. Setting up proper breeding programs requires significant infrastructure, which costs money. There's a shortage of people trained in quantitative genetics for aquaculture. And often there's just no national strategy pushing for and supporting this.
But aquatic species offer that high fecundity advantage, right? Producing huge numbers of offspring must help with selection intensity.
Oh, definitely. High fecundity is a massive plus for selection intensity. You have so many individuals to choose from.
So how do we leverage that, especially when you can't easily tag tiny larvae individually?
Well, that's the catch, because you can't tag them early on. You need sophisticated systems. You need dedicated tanks or facilities to rear families separately until they're large enough to tag so you know who's related to whom.
Right. Adds complexity and cost.
Exactly. It requires investment. And this is where public-private partnerships become really important, especially for species crucial in developing countries. Plus, you need government buy-in, investing in training, providing extension services to farmers, and monitoring the genetic status across the board, broodstock suppliers, hatcheries, farms to prevent accidental inbreeding and keep diversity up.
Okay, if we connect this to the bigger picture, all this genetic potential and improvement must also be managed equitably. What about access and benefit sharing, especially when we consider traditional knowledge?
Yeah, that's a critical layer.
Right.
There are international frameworks, like the Nagoya Protocol, meant to govern access to genetic resources and ensure benefits are shared fairly.
But how well does that work for fish?
It's tricky for aquatic species. It's often hard to trace where genetic material actually came from. The seed markets are very fluid, crossing borders easily, and national laws specifically covering aquatic genetic resources can be unclear or just missing. And this ties into recognizing the contributions of indigenous and local communities. They often hold vital traditional knowledge about local species, unique strains, and sustainable practices. That knowledge needs to be respected and integrated.
So what does this all mean for moving forward? It sounds like we need a comprehensive and multifaceted strategy for the entire industry.
Absolutely. To really unlock the potential of aquatic genetics, we need a holistic approach, working on multiple levels. We need things like standardized terminology, global information systems like AquaGRS, so we can actually track and share data effectively.
Okay.
We have to prioritize conserving those wild relatives and also unique farm types. We need to apply systematic risk analysis to any introductions. And crucially, promote selective breeding through national policies, maybe financial incentives, and build capacity, train more people.
And the equity piece.
Yes, and strengthen those access and benefit sharing mechanisms, making sure they work for aquatic resources and genuinely respect traditional knowledge systems. It's about fairness and long-term sustainability.
So the core message then is unambiguous. Improving the genetic foundation of aquaculture isn't just, a nice to have. It's essential for the industry's resilience, its sustainability, and its ability to feed a growing planet.
Precisely. We're dealing with almost 700 different species being farmed. That complexity demands targeted strategies, much better data systems, and real international collaboration. It's about making sure these genetic resources are a continuing source of innovation, not a bottleneck or a vulnerability down the line.
Makes perfect sense. So for our listeners, consider the profound impact that mastering this genetic potential could have, not just improving one type of fish, but potentially reshaping the global food system. What new frontiers of sustainable production could this unlock for aquaculture? Something to think about.
If you enjoyed this episode, make sure to follow the Aquaculture Podcast Show on your favorite platform. And don't forget to follow us on LinkedIn, Instagram, and Facebook to stay updated on the latest episodes and industry insights. Thanks for tuning in, and we'll catch you next time.